Now let's look at the nomenclature of the alkyne. In this video here, you are going to learn and master the various rules, steps in order for you to name simple alkyne to what complex alkyne. So you want to stick to the end of this video. So I'm going to walk you through all the rules, but first of all, there are some certain things you need to know. Now when we're talking about alkyne, alkyne have what sp, right there, and they are what triple bond. So now whenever you see a triple bond, is what is an alkyne. So every alkyne have what a triple bond. You get, and the bond angle is what 180 degree, and it's called unsaturated. Unsaturated is what is unsaturated. So these are things you need to know when it comes to what to alkyne. Just that. So as we move on, you need to understand how to name them. So let's move towards step number 1 in naming your alkyne. Step 1 or rule number 1 to what name alkyne. Step 1, identify the longest carbon chain containing the triple bond. The longest continuous carbon chain containing the triple bond is selected as what as the parent chain. The surface alkyne is YNE, which I'm going to explain to you. So, if for example here we have CH3, C triple bond, CH2, CH3. So now let's say we have something like that. I'm going to show you skeletal structure. Now, because here we have a triple bond is what is the alkyne. And alkyne are derived from the alkanes. So remember here we have alkanes. So when you remove what the AN, I play what with YNE. Here we have what alkynes. You see that? So it now depends on the numbers of the numbers of carbon atom, right? So if for example here we have so here 1, 2, 3, 4, 5, 6. Now which now go to be what hexyne. It's called hexyne. Is what is hexyne. So for example here we have so now let's say we have this one here. How do you name these compounds? So here we have a triple bond, right? So if I start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this one is straight. So here we have this one, here we have this one. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Let's have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see that? So from here to here is what is 9, but from here to here is what is 9. Can you see that? So my parent chain here that contains the triple bonds is what is decyne. Decyne. So that is what rule number 1. So rule number 1 is to identify the longest continuous carbon chain containing the functional which is the triple bond. This is that once you have identified that finish. So once you have identified that, then you have to what to name it. And the name are derived from what from the corresponding alkene. Just remove the AN and play what with YNE. So that was rule number 1. So let's move to what rule number 2. Rule number 2, which was step number 2, number the carbon chain. Number the chain starting from the end nearest the triple bond to give the triple bond the lowest possible number. So now when it comes to what rule number 2 or step number 2, now after you have identified the longest carbon chain that contains the triple bond, the next thing you want to look at is your numbering, and you must number in such a way that the triple bond must have the lowest possible number. Just and the triple bond must have the lowest possible number. So let's take, for instance, here, let's take this guy. Let's take this guy here. 1, 2, 3, 4, 5, 6 hexyne, right? Now, but if I start from here, now let's say CH3, C triple bond, CH2, and what CH3. Now, if I start from here, we have 1, 2, 3, 4. Carbon number 4 carries what the triple bond, right? But when I start from here, 1, 2, carbon number 2 carry what the triple bond. Now, the rule said that the carbon atom that carry the triple bond must have the lowest possible number. So so you're going to start from this side that gave me what 2, instead of this side that gave me what 1, 2, 3, 4, 4. Do you understand? So you're going to be 1, 2, 3, 4, 5, and what and 6. So the name is going to be what 2 hexene. 2 hexine. Do you understand? Or eggs 2 what I. That is it. This is what you need to understand here. Let's look at this guy. Let's look at this guy here. So when I have like this, can I from here to this point here, right? So how do I know by associated with that? The carbon atom that carry the triple bond must have the lowest possible number. So if I start from here, 1, 2, 3, 4, 5. When I start with 1, 2, 3, 4, 5, 5, 5. Just on 5, 5. So in a situation like this, where you have 5, 5, what will be the correct numbering? So this is where the next comes in here. If the triple bond is equidistant from both ends, number from the end nearest the first substituent. So look at something here. When I start from here, 1, 2, 3, 4, 5. When I start from here, 1, 2, 3, 4, 5. So it's going to be 5 decine. 5 decine. Do you understand? Now here we have a substituent here. So because number from both sides gave me 5 decine, then I'm not going to consider what the substituents. So the number is going to favor the one that have this one the lowest possible one. Do you understand? So this also is clear to this one point here because 1, 2, 3, 4. We have 1, 2, 3, 4, 5, 6, 7. Do you understand? So the correct number is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is where I'm going to start from. That was rule number 2 or step number 2, as easy as that. Now let's do some practice problem. Let's do some practice problem before we move towards step 3 or root 3. So for example, here we have CH3, C. Okay, what will be the longest continuous carbon chain here? Please pay attention here. What will be the longest continuous carbon chain at this point? So remember, here is what my triple bond. There is no I can count away from the triple bond. I must count into the triple bond here. So here are my triple bond. So I can say here going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So here I'm going to have 8. So 1, 2, 3, 4, 5, 6, 7, 8. So the longest continuous carbon chain that carries what the triple bond is what is what 8. I'm going to be octane. Octane, right? You're going to be what octane. So but what the position? Of course, it's going to be 1. So because we have to start from here. 1, 2, 3, 4, 5, 6, 7, 8. So the parent's name now. The parent's name now is what? Is 1 octane or octane. That what rule number 2. And now some of you will say, ChemChris, what about all these substituents here? Calm down. We have to do those ones. Let's take one step by step. So let me give you another one for you to try. If, for example, here we have CH3, CH2, C. What will be the name of this guy here? So drop at the comment section. What is the name of this compound? What is the name? What is the parent name? Drop it at the comment section. Step number 3, identify and name substituents. Identify any substituents, alkyl group or any other group attached to the parent chain. Name the substituent and their position on the chain. Step number 4, assemble the name. Combine the name of the substituent in alphabetical order with the parent chain name. Use hyphen to separate number from the letter and comma to separate numbers, which I'm going to explain here. So let's say here we have CH3, C. So now let's look at this. Let's look at this one here. How do we name compound like this? Pay close attention here. Now I want to combine every of the step 1, step 2, step 3, and step 4. So how do we name this here? So yeah, now fair for what the parent name. Parent name is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? So it's going to be what? Exine, right? It's going to be exine. Now, how will I number it? I must number it such a way that the triple bond must have the lowest possible number, right? So if I start from here, 1, 2, 3, 4. Count number 4 is kind of the functional group here. When I start from here, 1, 2. Count number 2 is kind of the functional group, the triple bond, right? So now I'm going to start from here. So it's going to be 1, 2, 3, 4, 5, 6. Can you see that? Now, yeah, going to be 2 exine or x2 ion, right? Now, if you find out very well here, I can number 4, I have a methyl group here, right? A methyl group. So what will happen here? So it's going to be 4 methyl 2 exine. As easy as that. 4 methyl 2 exine. Or you can say 4 methyl x2 ion. Can you see that? So that is the name of this one here. Now let's do another one. Here we have this one. Here we have this one here. So let's name these compounds. So if, for example, here you are being given this kind of structure to name, how are you going to name that? So let's follow each of the rules and step in order for us to name this one here. So here we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Good. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now let's say you have been given this kind of structure here. How do we name this structure? Right? So therefore, take the longest continuous carbon chain. That is the chain that have the highest numbers of carbon atoms. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So we're going to be what? Decyne. It's going to be what? Decyne. Right? Now, if I start from here to here, is decyne. Here I have this guy, I have this, and I have this here. You see that? So how many substituents do I have? I have 3 substituents. An ethyl, a chloro, and a bromo. Right? So now we have 3 substituents here, 3 different substituents. Now, where do we not start our numbering from? That would be the answer, the question. How do we start our numbering? Where do we start? What direction are we going to name it? Now, please pay close attention here. So now let's see the position of the triple bond when we start from different side. So here we have 1, 2, 3, 4, 5, right? Carbon 5. 1, 2, 3, 4, 5, carbon 5. So starting from either end gave me 5, 5. Do you see that? Coming from either side gave me what? 5, 5. So what will be the correct number here? This is you are not going to consider the substituents. Now, when you come from both sides, if both end gave the same mass of what? Or triple bond here, then I will number in such a way that when I sum the position of the substituents, it must give me what the lowest possible number. So I'm not going to use what the substituent now to get the direction of what of the numbering, not this triple bond again, because triple bond gave me 5, 5, right? So now if I start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Now, when I sum that position here, I get about 4, I have what an inside, right? 4 plus. I count about 7, I have what a bromo here. 7 plus. I count about 8, I have what a chloro here. 8. Do you see that? So when I sum that together, it's going to be what? 19. 19. No, it's not 19. Okay, going to give what? 19. So then when I start my number from here, 4 plus 7 plus 8 going to give what? 19. Right? Now, what about if I should start from this to that point? So what about if I start from here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now let's sum that position here. 1, 2, 3. I count about 3. I have a chloro, which is what? 3. Plus. I count about 4. I have a bromo. 4 plus. I count about what? 7. I have what? I have 7 here. Okay. So if you sum that together, you got to go up 14. You see that? So now, when I start my number from here, it gave me what? 14. But when I start from it gave me what? 90. So which is the correct one? 40 is what is the correct one, because it gave me what the lowest possible number, right? So now, what I want to do, let me write this list out. Let me write this list out. Now remember, my parent name is already what? 5-hexene, right? So what will happen here? I'll write this place. So let me just bring out what the substituent at. Let me bring out the substituent. So here we have 3 chloro. I can't about 3, I have a chloro here, which is going to be 3 chloro, right? I can't about 4, I have a bromo, right? Which is called 4 bromo, right? I can't about 7, I have ethyl, which is called 7 what? 7 ethyl. Nice one. 7 what? Ethyl. So now you are going to combine this together. You are going to combine this together. Here is parents. Here is what is here are what the substituents. So what happen here? You must arrange them alphabetically. You must arrange them what alphabetically. So B will come first in alphabetical order before what C, and C will come before what E, right? When you rank it in alphabetical order, you see B first, C before what E, right? So when you now combine it together, it's now going to be 4 bromo. 4 bromo. Here we have what? 3 chloro. There we have 7 ethyl. There we have 5 decyl. So that is name. So this is what the first video on what nomenclature of the alkyne. And these are the fundamental rules or steps you can use to what name alkyne. So we are going to end this class here. In our next class, when it comes to alkyne, we have to do complex structure. Yes, I hope this video is helpful. If this video is helpful, please leave in the comment section that this video is helpful. I'll be dropping some example for you to try. So you go ahead and name this structure for me. So I believe this video is helpful. Go ahead and name this structure. So see you in the next class.